I've written a small code which will help us to connect our ESP to any Wi-Fi network, or it will also scan the Wi-Fi networks around the ESP. We start by including the Wi-Fi H library, which gives the ESP32 access to its Wi-Fi hardware obviously. I then define two variables, one is flag and one is done. I'll explain this later. Then I have a setup code. Inside setup, serial communication is started. The ESP is set to station mode. Here you can see, meaning it behaves like a client, not an access point. We also disconnect from any previously saved Wi-Fi networks to make sure we only scan. This is very important. And the station mode is also very important. Then there is a delay of 100 seconds which will ready the microcontroller for the next operations. The actual scanning logic is inside the scan method. Wi-Fi.scan networks listen for Wi-Fi beacons frames and return the number of networks found. This is the method. Number of networks within the range of the Wi-Fi IC will be inside and stored in this intent variable. If n equals 0, then there are no Wi-Fi networks within the range of the IC, and else we will do some logic. We will print at first the number of networks that are in the range, and then there's a for loop. The for loop will print a network name or the SSID, the RSSI or the signal strength. I will tell what's it. Then the number of channels on which the network is. I'll explain this also, in the encryption. Here I am printing the flag, this variable. Why is this? Because my code will run 5 times. 5 times we will scan. So if I open the serial monitor from here, you can see the serial monitor, and if I start reset, starting Wi-Fi scan, you can see at first scan 8 networks found. Second scan complete, 9 networks found. Let the scan end, then I'll tell. After the scanning, you can see some results. Network found, 8 network found, 6 networks found. Let's talk about the last one. The prominent one is the first one, which is mine. That's Neil_4G. This is the name or SSID. RSSI refers to the signal strength. The lesser the value, the more is the strength. You can see all are in descending order. Best strength, worst strength. What is the channel? Now, channel can be thought as a lane. 2.4 GHz Wi-Fi is a 3-lane highway which uses channels as 1, 11 and 6. Fourth one is very uncommon. Let us see through a picture. In Wi-Fi terms, channel is simply a small size of radio frequency that our router or modem use to send and transmit data and receive data. Think the entire Wi-Fi band, this entire band, as a big highway, and these channels are small lanes on the highway. Now what you can see here, 1, 2, 3, 4, these are intersecting, right? These lanes are intersecting together, which is not good. That is why we use lanes which do not interfere, like the channel number 1, channel number 6 and channel number 11. See, they are discrete, they do not interfere. Each channel width is 22 megahertz approximately, and this is a 2.4 gigahertz band diagram. So there are approximately, this starts from 2400 megahertz and this ends at 2500 megahertz. Now the entire band is divided into multiple channels, but we use 1, 6 and 11 mostly. Because of this overlap, most channel interfere with nearby channel. For example, you can see 3 and 1 are interfering. So when interference happens, multiple routers or devices try to transmit on overlapping frequencies. When signal collide, Wi-Fi devices must wait, and this slows down the data transmission process, which introduces latency. This also increases ping as well. This is why 2.4 GHz is often slower. It's crowded, noisy, and you cannot use 2.4 GHz in a crowded place where 100 and 200 routers are operating. At that place, it will be a huge mess. Like, there are radio frequencies in 2.4 GHz, microwave frequency use 2.4 GHz. It's very old and janked at this point. Now, if I show you a picture of the 5 GHz band, this one, you can see this is a 5 gigahertz band. 5 gigahertz has many more channels. As you can see, this 20 megahertz channel, there are approximately 24 to 23 usable channels at single time in the entire 5 gigahertz band. More channel and also channels can bond together. You can see this is a 40 megahertz channel which is made up of two 20 megahertz channel. Here the data transmission rate is 2 times as of the initial one. This is why Wi-Fi 5 is also faster than 2.4 gigahertz as well. And one more thing to include is 5 gigahertz is not very range effective. It means 2.4 gigahertz can travel longer distances, penetrate more thick walls, and can even transmit data over a longer distance only because the wavelength is longer. Its frequency is lesser. 5 gigahertz is greater than 2.4 gigahertz, frequency less, so wavelength is more, and if wavelength is more, penetration power is also more. That is why 2.4 gigahertz can penetrate longer distances and 5 gigahertz cannot. And 6 gigahertz are even more limited. And but 6 gigahertz is the fastest. It can send around 8 Gbps of data.